Yesterday we did a little bit of a mistake here. So let's just quickly go back to question 3 on page 61. The first two terms of the geometric series are so the first term is 100, then the second term is, what is it? It's 120. So our A is 100. And we are told that it's a geometric series. So R will be 120 by 100, which is nothing but 1.2. Fine. Then they are saying the kth term. So if we did not use, we would have said the nth or the nth term. So we are supposed to use the T sub n formula. Okay? Right. So they are saying that that term is the largest term that is less than 5,000. So the largest term, so that k term, T sub k, is the largest term that is less than 5,000. We know our A, we know our R, we can therefore use our T sub k formula. So A, R raised to the k minus 1, are you with me? Alright, are you with me? Give me T sub k. Same thing. So what is our A? 100. What is our R? 1.2. And they are saying it should be what? Less than 5,000. So from here it's just you working. So I'm going to divide throughout by 100. So I put 1.2 here. Raised to that power. That's going to be 50. Everybody understand? How we get to 50? And then since I'm looking for an unknown, which is an index, we are going to take log both sides. So I can just put k minus 1 in front here. And then I have log 50 here. Now this is not a fraction. So the inequality sign won't change. No? So I have got k minus 1. So we have log 50 divided by log 1.2. Right, so whatever that business is there, what is that business? What is that business? 20? Quickly. 21. No. You should stop giving me only whole number answers. Because this is inequality. Yesterday you did the same thing there when we were doing the quadratic equation. You were saying one answer was minus 21, but it was minus 21 point something. So please, give the full, at least up to 4 decimal places. It's 21.7?
Yes.
And so on.
Yes.
Right, so you're going to add 1, right?
Yes.
So k should be a term that is less than 22.4567. So therefore, our k should be what? 21. Term less than, is it 21? Are you sure that when you say log 50 divided by log 1.2, you get 21 point that? Okay. And if you add, you get a number less than 21, 22.4, blah blah. So the number must be 22.
It's less than.
Less than. No? Okay? So that's how you do that part. So now they say evaluate the sum. So now they say evaluate the sum of the first k terms. But we know k is equal to what? 22. So now it's a sum, and our r is greater than 1. We have our r.
Yes.
So we are going to use r greater than 1.
Yes.
Which formula is that? So
First one.
S sub k will be a in bracket, the first one. So we're going to take our r raised to that k minus 1 over r minus 1. Okay? So the sum of the first 22 terms is going to be our A being 100 and our R is 1.2 raised to the power of 22. Am I right? Minus 1 over 1.2 minus 1. Okay. Just give me the final answer and then give me the answer afterwards to 3 significant figures. So you should get something like 20 something thousand, no? 27,103 blah blah blah. Alright? So the answer is 27,100, correct to 3 significant figures. You understand? You always take the answer to 3 significant figures. It's not. I also took the pictures of the corridor. So we will see only. Are you done with this side? That was yesterday's question, and none of you could see. Yeah, none of you could see that everything was factorized wrongly, and you did not say anything. Anyway, they're saying the sum of the second and third term of a geometric series is 10a over 9. So the second term is going to be a r2 minus 1, which is just going to be a to the r. You follow? And the third term is a r3 minus 1, which is just a r squared. So the sum of them, so term 2 plus term 3 should give you this 10a over 9. So that means ar plus ar squared should give you, we got to that part yesterday, okay? Then it's going to be helpful, I believe you have done this part at least. It's going to be helpful taking out the a because we want to cancel the a, right? And also the question is saying that r should be positive. Né? They say r must be positive. So that is going to be, take out the a, so then you have r plus r squared equals to 10a over 9. Right, so you are dividing both sides by a. Provided a is not equal to 0, obviously. You understand? Because if a is equal to 0, you can't divide by 0. Okay, so now we are left with r plus r squared equals to 10 over 9. So maybe you can do what you can call cross multiplication. So that's 9 r squared plus r equals to 10. You see what I did here? So that gives you 9r squared plus 9r minus 10 equals to 0. Here was our problem. So 9 times negative 10 is negative 90. So you look for two numbers multiplied with negative 90, and if you add them, give you 9. What are those numbers? What are those numbers? You can use the quadratic equivalent formula if you want to, right? But I want to find what two numbers you get when you multiply. You get negative 90. And you add them, you get 9. Now check. So 90 is nothing but 3 squared, 9 times what? Times 5. Am I right? Times something else?
Times 2.
Times 2. Right, so we're going to find the numbers from there. 3 times 2 is 6. So what are the numbers? We can't use 9 times 10. Okay? So that one is out of the question. What about when we use 15, which is 3 times 5 times 4? Right? 15 comes from 3 times 5 and 2 squared. Yeah? 15 times 4. You follow? Okay? Now, one has to be negative, one has to be positive. So the negative will go on the 4. You agree? This is going to give you negative 90. And 50 plus negative 4 is going to give you 11. Not what we're looking for. Okay? So what is the numbers? We're very close. 16? 14 times? Times 6. Yes, sir. Alright. So it's 15 and 6, negative 6. So 9r squared plus 15r minus 6r minus 10. Okay? You could easily have used the quadratic equation formula, right? Yes? 3r. Then you have 3r plus 5. You agree? Minus 2. Then you have 3r plus 5. So here is where our solution is going to come from. Right. Remember that's negative, so one number has to be positive, one number has to be negative in our answer. So it's 3r minus 2 and what is the other one? 3r plus 5. Right. Here r is going to be nothing but 2 over 3, which is the required solution. Or here r is going to be nothing but minus 5 over 3. And we are going to reject this because they're saying the ratio must be what? Positive. Alright, I want to finish the mixed math because I realize those mixed questions are also very interesting. Although you might have started with your sigma notation, but those mixed questions are very interesting. Okay, so let's see how far we can get. The first one says, how many terms of the series? So remember here, this is now mixed questions, right? How many terms of, let's take it as it is, 2 plus 4 plus 8, yes? Plus and so on and so on, must be added to give a sum of, what is it? 510. So what do you think you should do here? First we must determine whether this is an AP or a GP. Okay? Is it an AP? Is it a GP? Yes. 4 divided by 2 is the same as 8 divided by 4, which is 2. So this is going to be a GP, and that is the ratio. Then also, our first term happens to be what? 2 also. Does that make sense? Right? So how many terms? How many terms? So we are looking for n. What are they giving us? They give us the sum. The sum of some terms gives you what? 510. So which formula are we using? Okay. We are going to use S of n over GP. And r is greater than x, so we are going to use a r minus 1 over r minus 1. Right? That one? Okay, so we're looking for n, and also because n is an index, probably we'll be using logs or indices, no? To find that value. So a is 2, and our r is 2 raised to n minus 1 over 2 minus 1. It should be what? 510. Well, this answer here becomes 1. Yes. So you can divide 2 out by 2. right? So you have got 2 raised to the power n minus what? Equals to 255. You with me?
Yes, sir.
And 255 becomes 256 if you add 1 to both sides of the equation. And 256 is the power of 2.
Yes.
And it's 2 raised to what power?
8.
2 raised to the power 8. Therefore, n equals to 8. This one is straightforward, no? You get it?
Yes, sir.
Okay, let's look at the next one. This one is kind of interesting. So, question 3, page 62. It says the first term of a geometric series. So the first term is 3 over 4. Then the fourth term, which is AR raised to the power of that, right, is, what is it? Negative 2 over 9. So, let me just clean this up. So this is AR cubed equals to negative 2 over 9. And then I have that, okay? So now they want me to find the common ratio, right? So we know what the value of A is, so you're going to substitute the value of A into this equation. So this could be your equation, your first equation, and this can be your second equation. So we say 3 over 4, R cubed equals to negative 2 over 9. Are you with me? So I'm going to get rid of this 3 over 4 by simply multiplying by what? It's inverse. So there goes nothing. Multiply by the inverse, which is, please work with fractions, don't work with decimals, okay? So R cubed becomes negative 8 over 27. 2 times 4. You with me? Right, to get R alone, therefore, you must take the cube root. The cube root of negative 8 over the cube root. Let me just put the whole thing. Of negative 8 over what? 27. So we do expect a negative number, right? Cube root of 8 is 2. Cube root of 27 is 3. So R equals to negative 2 over 3. Then there's a B part to the question. The B part of the question wants us to calculate what? The sum of? Okay, so we need to find the sum of the first 10 terms. So we know what A is. Our A is 3 quarters. And our R is, we calculate negative 2 over 3. Right. So A is a smaller value. Okay. Now you must be very careful here. There's something I want to show you. Okay, because it's very easy to make this mistake. So obviously we're going to use the formula where we're going to have our R, because it's like negative 0.6, no? 666. To the n minus 1. It doesn't matter which one. Okay, so the sum of the first 10 terms becomes our A, which is 3 quarters, then R, which is our R is negative 2 over 3. Are you with me?
Yes, sir.
And here's the thing now. Please, don't put the 10 here. Put it outside. You follow what I'm saying? This one should be raised to that. If you put it here, you easily make a mistake. The answer will be wrong. You follow what I'm saying? It could be that it's only taking the negative 2 raised to the power of 10 and not the 3. So put it outside. Then obviously minus 1. Again, as he is saying, that's why he likes his what? Anyway, you're going to say then, our R, well, I could have used the other formula. Okay? So it's negative 2 over 3 minus 1. Now, give me the answer there. Just punch it in your calculator and tell me what the answer is. Okay? 0.442. I'll give the answer correct to 3 significant figure. Is that fine? Okay? If you did not put that 10 on the outside, here, please. If you put it here, you get a total difference. So be careful with that. Can we go to the next question? I want to finish this week's questions. Question 4. It says how many terms of the series, now this is very important. This is the series 11 plus 13 plus 15 and so on and so on should be added, right? To equal to the sum of another series, to the sum of the first 6.
Yes, sir.
I'm tired of writing. To the sum of the first
Yes, sir.
6. Right? What is it? Terms. Or what is the series?
Negative 24 plus 48
GP.
Negative 34
plus 48
minus
96.
and so on and so on. To give you a sum of what? Okay. So first of all, what do you think is the our modus operandi? What are we going to do now? First, we must look at this one here, right? Because we need to find out what is the sum of the first 6 terms here. You follow? How many terms of this should be added? So we're looking for A. Alright? Isn't that so?
Yes.
Right. But we can find the sum of these terms, so the first 6 terms of this one. So we have to find what that sum is. But we now need to determine whether this is AP or a GP. So this sequence here,
So,
is it an AP or a GP?
so what can you tell me about it?
Say what?
What can you tell me about the ratio of them?
It's negative.
What can I tell you about the ratio? I believe that question should go the other way around. So the ratio is obviously negative because of the alternating signs here. Is that fine? So we are going to find a ratio that is. So first, our A is negative 24. Our R, according to him, will be 48 divided by negative 24, which is what? Negative 2. Right. So now we are going to find the sum of the first 6 terms. Okay? Of this particular sequence or series. Is that fine?
Yes.
Okay? So it's a GP, please don't forget. It's very easy that you might forget that this one here is a GP. That one there is not a GP.
It's an
This one here is an AP or arithmetic series. You understand? Alright, so let's find the sum of the first 6 terms here. Our A is minus 24, open bracket. Then I'm going to have 1 minus negative 2 raised to the power of what? 6 all over 1 minus negative 2. So please give me this answer. You see what I did there? Please don't put the 6 inside. Although in this case it won't do any difference, but you never know, we've calculated this stuff, okay? So what do we get?
Let's see.
504. 504. This is an arithmetic series. And our first term here is 11. And our common difference is what? 2. You agree?
Yes.
Now we are looking for number of terms. Right? How many terms should be added here to give you a sum of that?
Yeah.
So what are we looking for? We're looking for what?
The number of times.
Which formula are we using? T sub n or S sub?
Yes. It's a series. It's a series.
It's a series. So we want to know how many of these should be added to give you that. So it's S sub n. Right? So S sub n is the unknown. N will be the unknown. Is it not so?
Yes.
Alright. So remember I said this is a what? Arithmetic progression or arithmetic sequence. Series. So now you cannot use the same formula like what we're using here.
Yes.
So for S of n of this, it's n over 2, then 2a
Yeah.
plus n minus 1 times b.
Yeah.
So this is unknown. But we know that it should equal to what? 504. So n over 2 equals to 2 times a, our a being, I wrote it down, 11. Are you with me? Plus n minus 1, our d is 2 or negative 2. Should equal to 504. I can multiply both sides by 2. That gives me 1008. Okay? So here I have 22 minus 2 plus 2n. Is that fine?
Yes.
22 comes here.
20.
That gives you 20. It's 2n plus 20. That gives rise to a quadratic 2n squared plus 20n minus 1008. When we can divide this by 2, because 2 can go in 2 and 20 and so on the left and on the right. Common factor. So that gives us n squared plus 10n minus 504 equals 0. Good. Now, what are the two numbers?
18.
That's a minus.
Positive 18. Positive. Negative 28. Negative 28.
We know we
Negative
are using a
28.
calculator there.
Yeah. Negative 28.
Negative 28
Yes.
and
Positive.
positive 18.
That's right.
Negative 28 times 18. It gives you a negative answer of this. Is an answer. Is an answer. Is an answer. Is an answer. So the child is taking chances. It gives you what? Okay. But negative 28 plus 18 gives you a negative 10. So we must swap. This becomes positive, that one becomes negative. Ne? You understand that?
Yes.
Okay, then it will work. So positive 28 and minus 18. Again, feel free to use the quadratic equation form. Or complete the square. Right, n plus 28 should equal to 0, or n minus 18 equals to 0. N cannot equal to negative 28, but n equals to 18. So therefore, 18 terms. 18 terms here. If you add them here, 18, 11, 13, 15, 17, like this, you're going to get 500.
Concept is correct.
You understand? That's a very interesting question. That's why I said you should not just run away from this type of questions. Then there is question 5. The first and second term of the geometric series are, now things are becoming a little bit, what do you call it? It's like you know what you're doing. Right? So this is question 5. So we know it's a geometric series. They are saying the first term, which is a, is 10, and then they say the second term, which is a. Remember, we're talking here about the geometric series. Alright? So this is a r raised to the power is 11. Am I right?
Yes, sir.
So first term is 10. Second term is 11. We also know it's a geometric series, so r will be 11 divided by 10, which is nothing but 1.1. Does that make sense?
Yes, sir.
Find the smallest number of terms. So we are going to find the smallest number of terms such that their sum exceeds by, is it 8,000 or 5,000?
8 now.
The sum exceeds by 8,000. Okay.
So round up.
Say what?
Round it up.
Of course, because we are dealing with inequality. Né? Right. R is 1.1, so we are going to use the formula. SRN equals to A R minus 1 You're not getting a mark for that. So, smallest number of terms, our A is 10 in brackets. Then it's 1.1 raised to the power of n minus 1. This is raised to the power of n. Is that clear? Over 1.1 should be greater than 8,000. Should be 1.1 minus 1. Right, so if you are subtracting here, you get 0.1. And 8,000 times 0.1 gives you 800.
800 divided by 10.
I'll repeat. You get 0.1 here. And 8,000 divided by 0.1 gives you 800. And then 800 divided by that gives you. So far so good. So when you add that one there, it becomes 1.1 to the n equals to, not equals to, my goodness, greater than 81. Logs, right? So we're going to take log 1.1 to the n greater than log 81. This is not a fraction, so you don't have to change the inequality. You understand? So we're going to divide. Right, so while I'm writing, please do it. So what is n greater than? No, I'm writing fast and how you.
36,
46.
Yes.
I heard 36.
46.
46 point.
8.
So n should be equal to what?
8.
47. Are we together?
47.
Are we together? Okay. Question 6. In a geometric series. So again we are dealing with a geometric series. They are saying the second term. The second term. I just write AR, everybody knows, man. It's 2 minus 1. The second term is, what is it? It's 3. And then the first term, which will be AR to the 4th, are you with me? Is equal to what? 5.184. Find the first term. Good. So we're going to create two equations now. AR to the 4th over AR, and let's put in the equal sign there, huh? 5.184 over 3. Obviously the a's cancel. And then you are subtracting, so the ratios becomes what? R cubed. Now, 5.184 divided by 3 gives you a cube number, which is, don't worry, I'll wait. Give me a fraction.
216.
Good. 216 over? Because 216 is a cube number of what? Of 6. 125 is a cube number of what? 5. So R equals to the cube root of 216 over the cube root of 125, which is what? Right, but this is not